I stop at the multiplication.
Okay, you didn't get the modulus part. Now let me start from there. So I said, okay, like I mentioned in the last class, I said any that code, any code you write that has to run in your main function. Has to be in your main function. If it's not in your main function, don't get wrong. That won't run it. So we said, for instance, print 5. So I said modulo is just to get the remainder of something. If we say 5 divided by 3 now, we are going to have 1 remainder 2.
Yes.
So that's what the modulo is for. So it's to get the remainder of something. So if we run this now, we're going to get it.
Sorry, can you zoom your screen?
Sorry. Is it all right, or I should zoom in?
You can zoom it a bit more. Right. Yes, it's fine now. Okay, so the sign for the modulus is like percentage.
Yeah. If you want to find the modulo, you use the percentage sign. Okay. Is to get the remainder of something. If we run this, now, we say if you want to run this, you have to say that run and the name of the file. Operators. So you can see it's giving us. For Miss Toby, you should have a run button on that part. If you run it.
Yes.
So just let me know if that folder has finished downloading.
Okay. It is that.
All right. So now, Mr. Toby. Abi?
Sorry, please. Olalekon is fine.
All right, Mr. Olalekon. All right. So can you get it now? I'm saying modulo is just to get the remainder of something. If you say something modulo something, it's not going to get what that value is. Going to get the remainder. Let's use another value now. What is the value I can think of? Let's say 10. 3 modulo 10. It's going to say 3 divided by 10 is I think 2, right? Remainder.
2 remainder 1. 3 remainder 1. 3 remainder 1.
All right. It's 3 remainder 1. So now if we run this now, it's going to give us 1. It's the remainder we're after. If we use modulo, that means we're after the remainder. You can see.
Okay.
So it's not going to give us 3. It's going to give us 1. It's just to
so that means sorry, sir. So that means if I thought we run for a perfectly number that we divide it without any remainder, we only get 0.
Oh yeah, that's what I was trying to explain yesterday to Mrs. Toby. When we a use case for this modulo is to find if a number is even or odd. So you get if you want to find normally in mathematics, you want to know if a number is even or odd, you have to divide that number by 2. If it's divisible by 2 and it's giving you a 0 remainder, that means the number is even, right? But if you divide it by 2 and it's giving you 1 or any other value, that means the number is odd, right? It's even going to give you 1. That means the number is odd. So that's how we know if a number is even or odd in that. So if we say 10 modulo 2, it's going to give us 0 because 2 in 10 is 5 remainder 0, right? So that means 10 is an even number. But if we use 11 and we run it, it's going to give us 1. That means 11 is an odd number. If we continue like that with 12, it's going to give us 0 again. That means it's an even number. If we continue with 13, it's going to give us 1. That means 13 is an odd number. So that's it. That's an example, a use case for the modulo. Can you get it now?
Okay.
Right.
So sorry, one last question. Why do you have to put that run operators that in the terminal display answer?
No, it's to run the file. To run the file now. I can just type that something, but I mentioned in the last class, if you want to go back to the last command that you typed, and just hit the arrow key, the up arrow, to bring out the last command, and then you hit enter.
But sorry, on my own end here, I can actually run it without having to press that run operators.
If you run it here, it's going to open a debug session and all that. So I don't want to go through all that stress.
Wow. Sorry. I think there's a problem here.
What's the issue?
Okay. The zip file I just downloaded, I opened it before extracting it, and flutter.console.bin console bin is not here.
The bin is not there.
No, the bin is there, but Flutter, the
But,
Flutter thing you're talking about,
but BAT is not there.
no, it's not.
Wow.
Not. So what could be the problem? Because this is like the extra. This is I've never extracted anything from here. This is like the raw thing right from the Flutter website.
I don't know if I'll have the time to what I'm thinking. Because I want us to solve
Okay.
it. Because I want you to use your VS.
Yes, no problem. After the class.
All right. So you can just continue with the that part.
That's yeah, I'm on that part.
Right. So now we talked about module. So let's just continue with the next operator. Now we talked about arithmetic operators. That's your addition, subtraction, multiplication, division, and module. Today we want to start with relational equality and relational operators. Hold on. Equality and relational operators.
Equality and relational. So you say equality and relational what?
Operators. I can see on my screen.
Okay.
This is another type of operator. And that's so we have equal to sign. You want to check if something is equal to. See. Me, I have something they call ligature. That's why this is looking like one equal to sign. This is actually two equal to signs. You can see equals to sign. You have equal to. So if you want to know if something is equal to something, you have to say that thing, then double equals to sign the other thing. For instance, let me type something now. So, like I want to say, let me make this. You want to say 5 is equals to 5. And you want to check if 5 is equals to 5. So definitely this value is going to evaluate true. Because yes, 5 is equals to 5. You say 5 is equals to 2. You're going to evaluate to false. So if you want to check if something is equals to something, you use the equals to sign. That's to be 2. You have to use the 2. So you can see. You have to use 2 equals to sign. Check if something is equals to something. If you
How do you make the sorry? How do you make the equals to join, or it doesn't matter?
Yeah, it doesn't matter. It's because I said something. They call it ligature.
Okay.
For you, it doesn't matter. So that's why I'm just saying that my own might look like 1. There's actually 2.
Yeah.
So you want to check if something is equal to, use what you want to check, then use the double equals to sign, and then the other thing at the right. So now the double equals to sign is different from the single equals to sign. Remember, we use the single equals to sign during variable declaration and all that, and initialization. Like you want to make a variable name to have this value. Like, and if you want to use that equals to sign, you cannot use a value like this. Okay, you cannot name a variable 5. Like if you want to say var 5 is equals to 2, it's not possible. You have to use maybe a name. Let's say var n is equals to 2.
Yeah.
This is assignment. The equals to here. It means that you are assigning the value of 2 to the n.
Fine.
Like you are saying, you are making a space in memory. You are putting 2 inside, and you are naming that space n. So anywhere in your anywhere you reference this value by using n, like we mentioned in the last class. So this 1 equals to sign is different from 2 equals to sign. You cannot use 2 equals to sign here.
To assign.
You cannot use the 2 equals to sign because here what we want to do is we want to assign 2 to n. So 1 equals to is just for assignment. So to assign something to something. But 2 is to what do you call it? Yeah, 2 is
Alright.
like relational operator to check if something is equal to something.
Yeah.
So to check the relation. That's the difference between the 1 equals to sign and the 2 equals to sign. So like I said, like 5 equals to 2. We will evaluate to false. Take it because 5 is not equal to 2. So it's going to evaluate to false. When I want to check if 5 is not equal to 2, that's when we use, you remove the 1 equals to sign. You use an exclamation mark. Your own will not look like this one. Your own will look something like this. Join together. Take it. It's because I own that ligature I was talking about. So your own is going to look something like this. So if you want to check if something is not equal to something, you use exclamation mark and equals to sign. So now if we evaluate this, 5 is not equal to 2. It's going to evaluate what? Sorry, can you give me the answer? Hello?
Hello.
I can hear you.
Can you give me the answer? What would this be if we evaluate this?
True.
Exactly, it's going to evaluate to 2 because 5 is not equal to 2. So it's going to evaluate to 2. We remove the exclamation mark and we use double equals to, what is going to evaluate to?
False.
False, exactly. Because 5 is not equal to 2. So it's going to evaluate to false here. So we have talked about equal to, we talked about not equals to 2. So the next one is greater than, like a normal greater than length. So if we evaluate this now, 5 greater than 2. Evaluate this 5 greater than 2. It's going to evaluate 2.
Yeah.
I understand that. Because yes, definitely 5 is greater than 2. So this expression is going to evaluate 2. When we say 5 less than 2, it's going to evaluate 2.
False.
False. 5 is greater than 2, and we are saying 5 less than 2. It's going to evaluate 2. And alternatively, too, you can say greater than or equal to. Your own will be like this, so like I mentioned, your own will be something like this. So you can say greater than or equals to. That means if you say 5 greater than or equals to 2, it's still it will evaluate to true. If you say 5 greater than or equals to 3, it will evaluate to true. Use 4, still evaluates to true. Use 5, it still evaluates to true because 5 is greater than and is not greater than but is equals to 5. Abi?
Yeah.
So here it will evaluate to true. But once we go past that 5, we use 6 here. That's now saying 5 is greater than or equals to 6. Now it will be false. But if we take
Sorry.
all right, that's good.
How do you get this your greater than or equal to sign?
It's my own customization. I think I can help you with that. Maybe after the class, I'll find. I'll try to write it out, and you can just follow it. But yours should look something like this, but without this,
Exclamation. Okay.
you get without the space. Yours should look something like this without the space. So if we say 5 is greater than or equals to 6, it's going to evaluate to false, right? Now, hold on. If I say this, what is this expression going to evaluate to?
True.
True. No.
To be false.
False. False.
The reason is
Wait, do you say less than or greater than?
greater than.
Greater than.
So this sign is for greater than. If you want to, for reference, you can just use your right hand.
Okay,
Right?
false. So it's not greater. They're
So
equal.
it is not a greater than, they are equal.
Yeah, they're
It's
equal.
not greater than. But once we use
The
greater
equal
than,
to sign.
now it's going to evaluate to true.
Okay.
You get now. Alternatively, you can have less than or equals to. Just like I've explained that greater than or equals. So you get it now.
Yeah.
All right. Hold on. Now you have another keyword to check if something that is of some type. Like 5 here, the type of 5 is int, like I mentioned in the last class, is an integer. So remember, 5 is an integer.
Yes.
When we're doing variable declaration,
Yes. Because it's 1 and doesn't have decimal.
now we said var n is equals to 5. If we over on this n, you can see it's an integer. Alternatively, you can use int here, like I mentioned in the last class. So n is an integer. Okay, remember. So now if you want to check if something is of a type, you can say print n. We use this keyword called is. Let me type it here. Is this keyword. So I want to say print n is int. So if we print this, do you know what this is going to?
5.
No, it's going to evaluate to true. I told you this is to check the type of something. You want to check
Okay.
n is an integer. You can follow the English now. I want to check if n is int. If you print this now, we run this. I want to this. Run this. Let me print. You can see it's printing true because I ran this. Printing true because yes, exactly. N is an integer. But once we change the type, we want to check if n is a boolean. It's going to print out false here because n is an integer. We are checking if it's a boolean. You can follow. All right. So we use this is to check the type of something. So that's what this is keyword is. So I want to print out some stuff like we did in the last class with the arithmetic operator. I want to print. You can follow this now. Print 6 is equals to 6. I want to see it. 6 is equals to 6. Last. If we print this now, it's going to give us 6 is equals to 6. This is true. Let's print it now.
Yeah.
Because I mentioned in the last class, whatever you put inside this dollar sign on a daily basis is going to get evaluated and then returned as a string. So you see, 6 is equals to 6. This is true. This is 6 is not equals to 6. This second line is going to print false. Do you know why?
Yes.
Because 6 is equals to 6, and we are checking if 6 is not equals to 6. So it's going to print false here. Can you follow me, Toby? You don't understand anything, I can go back.
Yeah, please go back. It's reading from the second line first.
So from the first line, we are checking if 6 is equals to 6. Definitely, obviously, 6 is equals to 6 here. It's going to evaluate to true because 6 is equals to 6. Now I want to check if 6 is not equals to 6 here. But as you can see, 6 is equals to 6. But I'm checking if 6 is not equals to 6. It's going to give us, that's why it's giving us false. So you can follow.
That's why it's giving us what?
False.
Yes, false. I mean, like, why is it reading second? You said it's going to read second. The first second line is going to read first.
Yes. So you can see now, if you check my terminal, you see the first line is reading true. Second line is reading false. I see my terminal.
Okay, you said false, not first. I had first.
I said false. I'm sorry about
Oh, false. Oh, sorry. Okay.
Just check my terminal every time I use something. I want to check if 6 if 6 is greater than 3.
Sure.
This is going to give us true, right? There's no wrong.
Yeah.
Let's do something else. Let's check if 6 is less than 3. There's no wrong. Let's check if 6 is less than or equal to 3. So there's no wrong yet. I want to check if 4. I'm sorry for going so fast because I'm checking the time. So I want to check if 4 is greater than or equal to 4. Yeah. I want to use the is keyword. Let's check if 4 is a number. Now here we are going to use the is.
Sorry, the one on top, you said 4 is greater than or equals to 4, then equals to, yeah.
Oh, sorry. Sorry about that. It's all right now.
Okay, yeah, it's all right. Sorry, I want to ask. Assuming you go ahead to run that, what error are we going to get?
Which one?
I mean, the way you said before, that you forgot to change that.
It's
Yes.
not going to, this is like a bug. This is an example of a bug. Now,
Okay.
it's
Don't make it crash.
going to run. No, it doesn't necessarily going to mean that it will crash.
Okay.
Sometimes bug is not going to crash your system. It's going to give unexpected results.
Oh, okay.
Here we want to check if 4 is greater than or equals to 4 because that's what we are expecting. But here we're evaluating 6 is greater than or equals to 3. So you can see the issue now. So we are expecting this one to evaluate, but we are evaluating something else. So you can see this is a bug, and this kind of bugs are hard to catch because it's not going to crash your program. It's not going to do any harm to your program, except that it's going to give you unexpected results. Like something like this kind of bug now, if it's in like a banking software that you are now giving people free money because of this kind of bug, you can see the problem. So this kind of silly mistakes, you get to make them once in a while. It's just for you to debug. Thanks for bringing it back. Now we want to check if. Hey, look, can you hear me?
Yeah.
I want to check if 4 is greater than or equals to 4. Now here we said we want to check if 4 is a number. We're checking if 4 is int, is of type int. That's what the is keyword is for. Now I want to check again is if 4 is not a boolean. Friends, 4 is yeah, you know, if you want to negate something, that's when we use the exclamation mark. That time that we used print 6 is not equals to 6. We use exclamation mark, right?
And equal to.
Yeah. So if you want to negate something, that's when we use that exclamation mark. So we want to negate the is now. We want to say it's not. I want to check if 4 is not. Sorry, we use it here. Let's check if 4 is not a Boolean. Okay, it's just like here when we say wanted to check 6 is not 6. So that was like the same thing. We want to check if 4 is not a Boolean. So here, what we should expect here is true. Right? Because 4 is definitely not a Boolean. So this should print out true. But we had said 4 is, if we had said we wanted to check 4 is a Boolean, this is definitely going to print out false. Because 4 is of type int, not a Boolean. They call it.
Sorry, but Boolean is just a true or false
Value, yeah.
output.
Yeah, true or false value. That's it. Okay. So the type of bool is different from type int. That's why we have said 4 is okay. It's because 4 is an integer. So Boolean is a different type. So now we just wanted to check 4 is not a Boolean. Definitely it's true because 4 is not a Boolean. You can get it. Can you get it?
Yes.
Yeah.
So now finally we want to run our first one check. Right. So you can see the first one we check if 6 is equal to 6. It's giving us true. Now let's check if 6 is not equal to 6. Because definitely 6 is equal to 6. I'm checking it. We check if 6 is greater than 3. It's giving us true. Yes. Yeah, I wanted to check if 6 is false. 6 is we check 4 is greater than was 4. No 4 is not greater than it's 3 was 4 is of type. 4 is
Oh, you're breaking.
hello.
Your this thing is breaking.
How about now?
It's
Better.
better now.
All right, now we want to check if 4 is not a Boolean. This one is just like English now. You can see if 4 is not a Boolean, you can see it's giving us true because it's definitely not a Boolean. 4 is an integer. Check and get the analogy. Hello.
Yes,
Yeah,
that is what that's what a test type is used for.
The is type. The what? The test type. What type?
Yes.
What type?
Test type, like I think you are trying to explain to us what a test type is.
What do you mean by test type? Is elaborate.
Is in your notice what one of the things you typed at the top.
Oh yeah. Type tests. Right.
Oh, sorry.
Type
I mean
test.
type test.
Yes.
Sorry.
We have his and we have is not. Yes.
Oh,
Yes.
Okay.
That's the code we wrote here. We checked if 4 is not. I told you the exclamation mark is for negation in this context because in some other cases we use exclamation mark for something else. We'll get to that soon. But here in this context, exclamation mark here is to negate this value. To negate if 4 is not a Boolean. So here, exclamation mark is for negation. So here you can see we said 6 is not equals to 6. Exclamation mark is for negation. I so you can see now it's exclamation mark. What's this? All right. Let me do something quick.
Okay, you deleted them.
I wanted to show you something.
Okay.
right. Let me take this in. You know, this is going to give us what is it going to give us?
True. An answer.
Yeah,
Okay.
true. It's going to give us true because 6 is equals to 6, right?
Yes.
All right. We can negate it. Like I said, you can use negate exclamation mark. If you want to negate the whole expression, you can just put it in parentheses like this. And then outside, you can just use that exclamation mark.
You're
Instead of it-
breaking.
Hello.
Okay, can you hear me?
All right. I said if you want to negate something, you know this value inside this bracket is going to give us true because 6 is.
Yeah.
But if you want to negate the whole expression, you can just
Okay.
put them inside the curly braces, a braces, I mean, inside a bracket like this, and then use your exclamation mark. So we know 6 is equals to 6 is going to give us true. But now we are now saying, okay, negate the value. So if we print this out, it's going to give us false.
So what if we put the exclamation mark beside 1 equals 2? That's
Hold on, let me run this first so you see.
not equals to. Sorry.
No, hold on. You can see, instead of it to give us true, because this is true, it's going to give us false
Yeah.
because we are negating the value. Now, if
Yeah.
we can go crazy and use the exclamation mark here. You know, normally here, 6 is not equals to 6. It's supposed to give us what?
False.
False here. It's going to give us false here. Now we are now saying after evaluating this expression, we put it inside a braces, a bracket, and we are negating that false value here. So if we negate the value, it's going to give us what?
False.
It's going to give us true.
True. Sorry.
It's going to give us true.
Please come. What did you just say? Yes.
I said it's going to evaluate this expression here.
Yes.
Here, the answer here
Mhm.
is false.
Yeah.
Because
True.
This
Okay.
is not equals to false. Is not equals to 6. Is false.
Mhm.
So after
So
evaluating,
that one
after
not
evaluating that, we are now negating that with an exclamation mark.
which is true.
So
Yes.
now it's going to give us true, as you can see. All right. So let's go to the next assignment. So these are the assignments. We have the, I mentioned earlier that you want to assign value to a variable, use this equals to sign. Like we said, var t equals to, let's say it's string, let's say it's a string. T is a string. We are using the equals sign to assign this value, this LO value, to this variable name. So we use the equals to sign to assign a variable. So it's different from equal to equal. And so it will not even allow me. But this one is to evaluate is to check if equals to L. So you cannot do that here. So if you want to do that, you have to get rid of that var. Oh, if you get rid of that var, no, T is not defined. Not defined T yet. T is not a variable yet. Now T is not a variable. Now we're now checking if T.
That is not PF.
No, it's just a string. You know, I mentioned
Okay.
last class that if you want a string, you can just use your single quote. Anything is valid as single quote is a string. I just use the random letter just to show you something. So here, 1 equals to sign is to assign the value. We are assigning this value. So here, T holds the value EF. Now we are now checking if T is equals to LO. So do you know what is going to print out?
False.
False, exactly.
Okay.
Because here, T is here. Let's note it out.
Yeah, yeah. And it has not been mutated.
So if we print T here, it's going to give us what? Because T is here. We are saying, is it equals to L? Let's run it. It's going to give us false. I think we said T here is L.
Hello.
It's going to give us true.
True. Yeah.
Because you can see T is hello and we are checking it. T is hello. You can see it's giving us.
So you basically don't have to use the print to check, because when you just kept T equals LO, it still brought out the false.
No. When I just used, when I didn't use that print, it's not going to print anything out. It's just basically just floating around. It's not doing anything.
Okay.
So I want us to print it out to see it. I just want to see the result.
Yeah.
That's why I'm using the print.
Oh, okay. Print.
That's why we use the print to print something on the terminal. All right, so I said the one equals to sign main assignment is to assign something. We are using double equals to sign. Is to check the relationship between them, if something is equals to something or not. So here we are talking about assignment operators right now. Let's not go back to that equals to sign. So equals to is to assign a value to a variable. Let's see. 1 equals to 3. So we declared the variable called num1. We are setting it to 3. If we print num1 here, it's going to print out 3, right?
Yeah.
So one, I said if you use var or you use the int, it means you can mutate the value. You can still mutate it because you are not using const or final. It's mutable here. It's mutable here. So we can say if you want to increase num1, you can just say num1. This num1 equals to 1. And let me just break this down. I said you can mutate what this value is. So we want to say this value now, we want to add 4 to it. Say, okay, now give me that number. Now it should now be, the one should now be, it should not be 3 anymore. It should be what the number was. That is, it should not be what the number was 4. So here, the number is referencing this value. 1 is 3. So if you print 1 right outside, print 1, it's going to give us 7. Here. But remember, here, it's still going to print 3 here. Because but here, we're now adding 4 to it. So we are expecting 3, 7. Here is number 3. Because here, number 1 is
Yeah. Another one is 4.
Yeah, this one is 3 plus 4. Here it is now 3 plus 4.
Okay.
Or if you don't want to go through all this stress of writing, number 1 is equals to number 1. You can just use this shorthand. See, number 1 plus equals to 4. So it's the same thing as what we had. Let me see for reference purposes. Let me just comment this out so you can see the difference.
Please come again.
Hold on. For reference purpose, let me. So this line here and this one that I commented out, they are the same thing. So I said, to save us some minutes of typing, you can use this shorthand. You can use this method or save us some time. So they are the same thing. This is an assignment operator. I say, no one now be 1 plus 4. Here you should print out 3 and 7 like you did before. 3 and 7. You can even use the minus sign. So if you use the minus sign, it's like you're saying 1 minus 4. So now if we use this now, it's going to give us minus 1. Right? Plus 3 and 3 minus 4 is minus 1. Right? Hello, can you hear me?
Yes.
Yes.
All right. So also we can even use multiplication like our normal arithmetic operators like we discussed earlier. So you can see 3 times 4 is going to give us 12. You can see no 1 is now 12. So you can even use division. I didn't mention this before. If you want to divide the value, it has to be of type bool. I'll tell you the reason why.
It has to be, sorry.
Sorry, it has to be of type double. You know, I said we have int, we have double. I said int is for whole number, something that doesn't have decimal points, right? Like if you want to say 3 or you want to say 4 or something, this one is their whole number, so they are integers. But once you start to use points, decimal points, it becomes a double. So you get. So that's the difference between integer and double value. So this one is a whole number, so it's an int. This one is of type double. So if we over around num1 now, you can see num1 is double. But if we remove the decimal points, if you over around it, it's an integer. So that's why that is not even allowing us to write it because it's going to give us a double type. See it. We now want to assign a double type to num. It's not going to allow us again. See, a variable of type double can't be assigned to a variable of type int. See, because they have different types. Take it. So now we have to put dot 0 here. You know, 3.0 is still 3, right?
Yes.
So for us to be able to divide this, and it's going to give us, definitely it's going to give us a double value. So that's why I have to use a double here. If we run this, you can see it's giving us 0.75. So because it's a double. Num1 is now a double. So you get now. If you like, I even use dot 0 here if you want. That one is your preference. But as long as you've used it here, you need to print out something. And see. Num1 is giving us 2.0. And divided by 4 is giving us 0.75. I even use modulo. There isn't modulo. You don't have to use double type again. Let's see what it's going to give us. It's giving us 3 because 4 divided by 3. Like I'm saying, hold on. I'm saying, they are saying 3 divided by 4. Definitely, this one is 0. You mean that what?
0.3.
Yeah, so that's what it's going to give us. So we want to, let's change this first. Let's say num1 is now 4. And we want to do the modulo with 3. So it's going to give us what? Let's give us what?
1.
1, exactly. So 4 modulo 3 is going to give us 1. So you can see. Next, so now we've talked about arithmetic operators, quality and relational operators. We talked about assignment operators. The next one is, I think the last one, the last operator we talked about is logical operators.
Practical.
Logical, hold on, I'll print it. All this, I like I mentioned earlier in the Slack channel, I said this course is incremental. Everything is leading to something. All these operators and greater than equals to sign, everything, they have their own use cases. After this operator, we're going to talk about control flow or conditional statements. You see why we made all these operators. You get it. So now the last operators I want to talk about is logical operators. Let me get rid of this one. So now we have two logical operators, the AND and the OR. So we want to check if, hold on, let me print something. Let's see var T is true. Please follow carefully so you don't miss anything important. Var F is false. So we have two variables now. We have T and we are setting it to be true. The over around it is of type O. You can see it's of type O. And we have F to be false. It's also of type O. No, and like I said, you can even use book here to declare your variable. So it's still the same thing. But because of, I said we have conventions in the DAT community. So if you know you are giving something a value, you don't have to explicitly specify the type. So you can just leave that to infer the type by itself. It's called type inference. So it's going to infer the type of this variable. So now it knows T is now a bool. So you don't have to use the bool keyword here. So now we declare two variables T and F, setting them to true and false. So now let's check. You can type this along.
So sorry, the sign for false is that double forward slash, right?
No. I want to explain logical operators. These are logical operators. This ampersand sign and this pipe will be forward slash. Is it forward slash or pipe? I think it's pipe.
Oh, it's pipe. It's pipe.
Pipe. You have two pipes.
Where is it located on the key? Or let's see it. Okay.
Okay. Have you seen it?
At the front of Z. Yeah, besides shift.
Oh, yours is in front of Z. Mine is beside the second
Shift key.
column. You have P. You have that QWERTY, QWERTYUIOP. Then you have the opening brackets, closing bracket. Then beside it, we have it. But it's on top. You have to press shift. The shift P. Hold shift, press it. You can see that's where you can have your double pipes in. First, we want to check if T and F. Also, sorry, are you following?
Yes, I am.
So now here I want to check if T and F. So in logic operations, if you are using the AND symbol, they are following. Please listen to this. You are using the AND symbol. The two sides, T and F, has to be true, or else it's false. Let me recap. The two sides has to be true, or else it's going to evaluate false. So here, the first side is T, and T is true, right? The second side is F, and F is false.
False.
So if you evaluate this, it's going to print out false. Because you are saying and. I want to say T and F. So the two sides has to be true, or else it's going to be false. Take your time to kind of like that. The two sides has to be true, or else it's going to be false. So that's you are saying T and F. If you had said, let's create another variable. Y is equals to true. If you had said T and Y here, it's going to evaluate to true because the two sides are both true. Okay, get?
So, sorry, I have a question. Can I go ahead?
can go ahead. Can go ahead.
Okay, if you're using this and now, so you said the true side has to be true for us to get a true
Result.
answer.
Yeah.
Yeah, if not, it will be false. So can if the true side is also false too, are we going to get a true answer or
Yes.
is it going to be false?
Hold on. It's going to be false. It's going to be false. So you get it as I said, it must be true. It must be true. Both sides must be true. So you get for that, let's create another variable for u is equals to false. Now let's try it. Let's try that. What you just mentioned. Let's see f here. F and u. F. Let's get rid of this one. Here, t and y should print out true. F and u should print out false. If I'm not mistaken. So you can see
F and U should bring out false.
false. Because F and U, because let me tell you something. If that is running this program now, it checks F is false. It doesn't even bother checking anything. Since you are using the ampersand, if it checks this one, F is false. It doesn't even bother checking this one again. Because this side is already false. So if I remember what I said, both sides has to be true before it can evaluate to true. Or else, otherwise it's going to be false. So once it gets here, see, oh, F is false. Don't bother evaluating again. The answer is false. Okay, get. Like we said, T.
Yes.
Sorry, T and F. Said T and F here. So you know T is true, right? And F is false. If we print this one out, out, it's going to give us what?
False.
False, yes. Because one of them is false. Check again. F is false. So it's going to give us, let's print it. You can see it's giving us false. Both sides has to be true. You can see both sides has to be true. It will be true before it can evaluate to true. You can guess. That's why we call it logic. It's checking if something is true or false. You can see both sides has to be true before it can evaluate to true, or else it's going to give us false. So you should note that. You should note that right now before we get to the second one, which is or. So this ampersand sign we just call it and. You can see and. We are saying T and Y. So T and Y has to be true. Let me use that in English. The first side, that's the left side and the right side, and the keyword left side and the right side has to be true before the value gives us true, or else it's going to give us false. So now the next operator is or. Sorry, Toby, can you have you found where that pipe operator is on your keyboard? The pipe symbol.
No.
So it's on your keyboard. You see, you have the QWERTY. You can follow along as I'm saying. Just check your keyboard, and then you have your opening brackets, closing brackets. Then the one beside it. Yes. So if you want it, you have to press Shift. Tap it.
No, no comment. I think that's it.
What's it? What's the
Underscore. It's bringing an underscore.
Okay, check the font of Z on your keyboard. The key that has backslash, then use Shift, that key.
There's no key that has slash at the front of Z.
At the front of Z.
Wait, are you talking of the slash
backward slash.
If you find
not forward slash, backward slash.
Okay, it's on top enter.
Yes.
Right here on my system on top enter.
Okay.
So just
thank you.
Shift.
Okay.
So it's going to give you this part of it.
Yeah, I've gotten the part.
2 times, not once. use it 2 times. So
Okay.
this one, you know, we mentioned this ampersand is for and. It's and. But this one, we call it or. OR. So now this one is not as strict as that ampersand. This one is just to get one, as long as one of them is true. You're going to evaluate it. Take it. You know, this one, the both side has to be true before it evaluates. But this one, only one, it only needs one to be true before it evaluates. Like we print this one, T and F.
That's your F true.
Yeah, okay, let me use F. So here is going to give us false, or here is going to give us true, because one of them is true. Let's print it out. You can see this one is false because obviously F is false. So one of them is false. That's the value. But here, one of them is true. So that's what that is doing. It gets to this part. It sees, oh, one of these values is true. So it doesn't even bother evaluating this other side again. Since one is true already, just print and gives us the result. True. So again now, that's the difference between the and or. So yeah, are you following? Hello.
Yes.
All right. Is there any problem? Are you getting it now?
Yeah.
All right. Good. So just have it at the back of your mind. If you are using and, both sides has to
Must
be
be the same thing. Must be true.
yeah, both sides must be true. Or else it's going to give us false. But if you are using yes, but if you are using or sign, only one has to be true. Yes. Only one has to. Here, if we say U, you know U is false.
Yeah.
F is false. If you print this out, it's going to give us false.
False.
It's going to give us
It's
false.
yours what? False.
Because U is false, F is false. So both sides are false. It doesn't have any true value. I know I mentioned that if you are using the or operator, only one of them has to be true. Only one has to be true. But it checks here, U is false. Checks here, F is false. So there is no true here. It's going to evaluate to false. You can even check T and Y. And see here, T is true, Y is true. One of them is true, so it evaluates to true. So you get. If you print this one out, you can see T or Y. That's why let me use that English. T or Y. Only one has to be true. T or Y. Yeah, it is T and F. See, I get it now. Hello.
Okay, I get it. Right. Yes, I get it.
So you know, I'm recording the session. So if you are not clear, maybe you are checking it some other time. Just watch this part. I will try to kind of edit the video and post it on YouTube. So you can just check this session. Right. Now, so the next, we are done with operators now. So we are done with operators. I think we have overused our time. Hold on, let me check. The next one is control. Let me see. I don't think we can do that today. Do you recommend? Do you reckon we continue with in the next class, or what do you think?
Next class, please. My head is hot.
yeah, it's normal. Don't worry. Once you get used to it, you see it's actually easy. So what I want you to do now, when we finish the meeting, you can just play with all these things. This true, false, or this or and. Just play with it so you can just check, kind of understand. It's not that you finish the session now. The next time you practice is when we have our next session. So don't do that. Just try to practice. All right. So I think this is where we end the session today. Let me end.